Welcome back to this example of finding powers. So what is it called? Matrix exponentials. No, not matrix powers. Matrix powers. This one, like I mentioned, this might be a little bit longer because it's a 3x3 matrix. So let's get started right away. So as always, we have to find our diagonal matrix. So we have to find our characteristic equation and find the roots. So this would be this 3, 0, 2 minus lambda, 0, negative 2, negative 2, negative 3 minus lambda. And as always, we are going to do, well, I'm still going to do the first row because we have 0. So this will be 2 minus lambda times 2 minus lambda times negative 3 minus lambda minus 0. Cool. Then we have plus 0. Then we have minus 2 times, now we're going to do this one, and this would be 0 minus 3 times 2 minus lambda. Cool. So, cool thing about this is, let's actually simplify this a little bit further. We'll have 2 minus lambda quantity squared times negative 3 minus lambda plus 6 2 minus lambda. So now we can factor out the 2 minus lambda, and we will get on the left over here 2 minus lambda multiplied by 2 minus lambda times negative 3 minus lambda plus 6. And so we can simplify this down. This would be lambda squared plus 3 minus 2 plus lambda minus 6 plus 6. So the 6 cancel out. So this would be equal to 2 minus lambda, factor out a lambda, times lambda plus 1 times lambda. That's equal to 0. So our eigenvalues would be 0, negative 1, and 2. Cool. We're, what is it, a third of the way done. So now, I guess a fourth of the way down. Now we have to find your vectors. So we're going to start with lambda is equal to negative 1. So this will give us 3, 0, 3, 0, 3, 0, negative 2, negative 2, negative 2. And so our eigenvector will be 2, 1, negative 3. Because this will be 6, 0. Take that back. This will be negative. This would just be positive 3. So we have negative 6, 0. No, I had this right. Yeah, so it'll be 6. Oh, this is all positive. There you go. So it'll be 6, 0, minus 6 is 0. Then we have 0, 3, minus, that won't work. Okay. So the first two are right. Not first two. The last, the first and second one is right. 2 and 3. And so to cancel out that one, this will have to be another 2. So now that'll be 6 minus 6, and then 6 minus, okay, cool. So now when lambda is equal to 0, we have the regular vector, not vector matrix, since that remains unchanged, 2, 0, negative 2, negative 2, negative 3. This is a 3. That's an ugly 3, but that's okay. So now we have, oh no, it's a 2, it's a 2. Whoops. So this would be 1 and 1 and 1, because we have 2 minus 2, And then the middle one will also be 1. And our last one will be when lambda is equal to 2. And that will be 0, 0, 3, 0, 0, 0, negative 2, negative 2, negative 5. And that will be, because we have a column of 0, then that's just going to be 1, and the others are going to be 0. So now we have our invertible matrix S, and that will be 2, 2, 3, 1, 1, 1, 0, 1, 0. Our diagonal matrix is going to be, because this was from the eigenvalue 1, this one 0, and this one 2, being negative 1, 0, 2. And so d to the 5th will simply be negative 1, 0. Now this one will be 32. And now to find the inverse of S, which is the long part of this example. So S inverse. So as you remember, you write the original matrix on one side, and then the, what's the thing called? Not the, it's an augmented, the identity on the other side. And so what we can do is get rid of this, not that, take that back. Get rid of this, 2 into 1. Same thing goes with that one. So we are going to add, no, subtract. So this will be 2, 1, 0, remain unchanged. We're subtracting, so this would be 0, 0, 1, and then this would be 1, 0, 0. And so then the first one remains unchanged, and then we are subtracting, so it'll be negative 1, 1, 0, then negative 1, 0, 1. And so now we can start just flipping these around. So we're going to move the second row to the third and then all that stuff. So we are going to have 1, 0, 0. This would be 0, 0, 1. This would be 2, 1, 0. So this will be 1, negative 1, 0, 1, 1, 0, 0, and then negative 1, 1, 0. And then lastly, to get our identity on the left side, we will subtract this 2. So this will be giving us negative 1, 0, 1, and the last row will be unchanged. The middle one, it will be twice minus, so it'll be 1 minus negative 2. It will be 3. This will remain unchanged, and then we'll have 0 minus negative 2, just be 2. No, 0 minus 2. This will be negative 2, my bad. And that is our inverse matrix. So now all we have to do is just put it all together so that we know a to the 5th is equal to s to the 5th, not to the 5th, s times d to the 5th times s inverse. So that will be our s 2, 2, 3, 1, 1, 1, 0, 1, 0, multiplied by negative 1, 0, 32, multiplied by negative 1, 3, negative 1, 0, 0, 1, 1, negative 2, 0, and that will equal to the first matrix remaining unchanged, and then 0, 1, 0, times, so this would be negative 1 times 2, no, wait, negative 1 times negative 1, that'll be positive 1, and that'll pretty much be it. That's it. And then now we have the second one, it will be 0, 0, 0, because we have a column of zeros. Okay, and then we have negative 1 times 1, so negative 1, 0, 0. So this would just be negative 1. Second row, we have, this one we have a row of zeros. Because we have a row of zeros, that would just be 0, 0, 0. And then lastly, we have 0 times negative 1, and then 3 times 0, and then negative 32. The second one will have 0, 0, 0, so it will just be 32. Then we have 0, this will just be 0. And so a to the 5th will be equal to 2 times 1 is 2, times 0 times 0, so this will just be 2. And then 2 times 0 times 0 times 0, this will be 0. Then 2 times negative 1 will be negative 2 with 2 plus 2 zeros, be negative 2. In the second row, we have 2 times 1 is 2 times 0 plus 0 minus 32, so that'll be minus 30. And then we have 2 and 0, 0, 0, this will be 32. We have negative 2 with 2 zeros, so that should be negative 2. Last row is 3, just 3. And then 0, 0, 0. Then negative 3, 0, 0. And that is our answer. So that concludes this part of the video, and a cool little trick or a cool little property with diagonalization is the fact that you can raise matrices to higher degrees a much easier way by just finding the diagonal and just raising that one. And so yeah, I'll see you guys in the next video.